Welcome back to the Aussie Shed, gentlemen, for episode 9 of my twin turbo build of my right hand drive Nissan 370 GT, also applicable to the 370Z. As you can see here, I've been going at it with the welder. I've got more gas, so I'm able to run my back purge and everything like that, and finally start welding out the manifolds, building the dump pipes, fitting the wastegates, the wastegate pipes. It's all been going extremely well. Being that it's stainless steel, everything's been purged, so it's all real nice on the inside. The manifolds have had a root pass and then a pass with some filler rod over the top of that, just to strengthen up the joints. All of the thinner pipe have just been fused. They've all come up really well. Oxygen sensor bungs have been fitted. You can see down here I've got a cat fitted on there, and there's a V-band just here on the end of the dump pipe. The cats that I'm going to be using here, that's a 200 CPI cat. 100 CPI cats, not a huge fan of. Hey, mate, they stink. They're a bit of a giveaway. And I am trying to make this as legal as possible. There's no way it'll pass emissions with 100 CPI cats, so unfortunately 200s are the way to go. Not that I think that's going to be a real issue. As you can see, it's a 3-inch dump pipe that I've made up here. Basically the whole car is going to have a twin 3-inch exhaust system, so you know it's going to be able to breathe pretty well anyway. If you notice up here on the wastegate pipe, I've got a bellows fitted to it. Exhaust bellows are really good for pipes that are expanding and contracting at different rates. Your bellows is like a slip joint that goes in and out, and that is the only way that the bellows works. It purely is an in and out fashion. That looked a bit... I better not do that. But your bellows isn't a flex joint, like a sort of a typical flex joint. Like this is your typical flex joint. Now this allows, as it says, it's a flex joint, so it allows flex in these sorts of directions. But it doesn't allow expansion and contraction. Your flex joint doesn't move this way. It only moves flexing wise. Your bellows over there is the exact opposite. It doesn't allow for any flexing in this direction. It is purely for expansion and contraction. I have seen quite a lot of bellows fail, and it's always when people use them in the wrong situation. They use them as a flex joint, which is not what they are, and they will always fail. If they've got movement that's pushing left to right on them, they'll fail. Whereas if they are used as they are intended, which is as an expansion and contraction joint, they just last. They're really, really good. Same with your flex joint. Like all this kind of stuff, it's horses for courses. Flex joints are awesome if they're used in the right situation. What I'll be doing here is I'm putting a flex joint on the end of each of the cats here at the beginning of the exhaust system. Where are we? So there'll be a flex joint in that position, and then we're basically just going to 45 into the center, a big Y pipe, maybe a resonator or a long sort of round muffler inside, and then out to some other mufflers. I want to try and keep this as quiet as I can, you know, so it just doesn't sound ridiculous. Stealth is the go, ladies and gentlemen. Stealth is the go. So as you can see, it's all looking pretty good. Everything still fits really well. As you'd know from the last video, all the oil and water lines are done. This side is pretty much complete as far as all of the hardware goes, and I'm now working on the other side, trying to get it into the same position as this side. This is the most completed side. The other side, I have the turbo manifold up on the bench at the moment. We'll go up there and have a bit of a look. So this is the main log section of our driver's side turbo manifold, and you can see it's just been set up here for purging. Now this has had a root pass done on it, which is a pass with no filler. It's just fusion welded, and it gives you really good penetration all the way to the root, hence it's called a root pass. And what I will do with this, as I've done with the other manifold over there that we just looked at, I'll then go over all these joints with some filler rod because it does divot down slightly on all the joints, and it is a little bit thinner where the weld is than where the pipe is. So to fix that back up, I'll do as I've done over there, and I will run another pass over it. You can see these two pieces have been just welded around. They only have to have one pass around them. And yeah, so you can see the purge setup running here. And the reason I've got the manifold pulled apart like this is to make it easy to weld certain sections. As with all this kind of stuff, there are welds that are easy to get to, there are welds that are ridiculously hard to get to. So once you've got your manifolds made up, you basically have to pull them apart and weld them in sections in able to get to some of the welds. For instance, like you know, down in here sort of thing, or how do you get down in there? Well, basically you have to pull it apart and weld everything in sections. You know, you can get into some tight spaces, but others you can't, so you've just got to work out how to actually physically do it. And also, when you do weld it, everything moves around quite a bit. Things shrink, things buckle. So as you put it back together, you do have to tune up some of the joints to get everything back to where it was, adjust some of the angles slightly, just so that everything is back where it was. The turbo has to be in the exact same location. So you can see here, I've actually left this last joint here not welded, and that will be the last thing that I weld, because any changes that any corrections that I need to do, I will do on this joint. Now that will allow me, you know, the turbo sort of hangs off it here, that will allow me to sort of, you know, tilt this way, tilt that way, and just make sort of general corrections. That's how I did the other side. It worked out extremely well. I also have a purging manifold that I made up here to do them on. You can see this when it comes time to weld around the bottom of the flange and everything. It's just simply some aluminium plate, a hole drilled down through the middle, a hole drilled down this way just with a barb hose fitting, and this just connects up into your purge line. You just bolt your manifold down onto that, and this actually bolts down. You'll see this little bit of steel beam I've got here has matching holes in it, so this whole lot will bolt down together when it comes time to weld this out. Bolts through all in one piece, so it's really nice and solid to minimize deflection on the flange when it's welding. It probably will still deflect slightly, and this plate will have to be reflattened. I did have to reflatten the flange plate on the other side, and when it comes time to do that, I'll show you guys how to flatten a flange plate to sort of machine shop standards without using any special equipment. I roughly flatten these with my belt sander. It does a reasonable job, but it tends to take more off the ends than it does in the center, just because that's what the belt hits first. Kind of like how on your brake calipers, if you've got multi-piston brake calipers, you have smaller and bigger pistons as they go into the brake caliper, because if you apply even force across your brake caliper onto the rotor, it'll wear the outside of the pads more, because that's where your initial bite is. It's the same when you try to use a belt sander to flatten something. Even though the belt sander is flat, it does take more off your initial spot where the belt comes into contact with it. I've tried many ways to make that not happen, and it happens in varying degrees, and there's ways that you can kind of fix it a little bit. And you'll notice here that when the flange plate sits on the aluminium there, it spins quite easily, which tells me that it's high in the center. But what we'll do is, when it comes time, once it's all finished welded, I'll get this machine shop flat by using none other than a handheld 4-inch angle grinder, which are just going to be, no way, Trevor, there's no way you can do that. You just cannot get that flat with a 4-inch angle grinder. Well, let me tell you folks, I can. And you can as well, once I show you the technique. And I'm not joking here. I am going to use a surface plate as well, but you can use anything. You can use a sheet of glass, you can use a stone benchtop offcut, anything that's pretty flat, you can use to spot the flatness of your flange plates with, and an angle grinder. Anyway, I'll go into that in another video. But at this stage, it's all about the welding. So, as I mentioned, this is what's going on at the moment. This is our driver's side turbo manifold. It's going through the process of being finished welded. Once it's done, then it's back onto the engine. On here you can see this is the driver's side. Everything's pretty much pulled apart there at the moment, but as you know, all the intercooler piping and everything is already made. The turbo oil feed and coolant feed lines are all made and everything. It's just all been disassembled so that we can finish weld everything. Once the turbo manifolds are finished welded, I can then start working on the dump pipes and the wastegate positions and everything like we have on the other side. So that's where we're at the moment. Everything's progressing very nicely. Everything's going extremely well. I've had the body shell, which is sitting up there. It's bloody, you know, up and down like a bride's undies constantly to check clearances. I don't think I will be able to do this without the hoist. It certainly would be hugely harder, and it's hard enough as it is, but to be able to just constantly drop the body back down and put the two together to check clearances, yeah, it's just so good. And everything on the other side that you've seen, we'll go back around there and have a bit of another look over there, just because it's a little bit more fun looking at that than this. So everything here clears perfectly, folks. There's no issues. You know, the wastegates and the wastegate pipes and the exhaust and everything all has plenty of clearance on the car. There's absolutely no issues when it gets to this point. There's actually quite a bit of room at the back of the turbo there, because you think your standard exhaust manifold is kind of quite thick in that area, so there is quite a bit of room there. Realistically, the big issue here is down the side where the turbo is mounted. So yeah, it's all really good. So I'm pretty keen to get the other side up to this level. So at the moment, it's all about welding out the manifold for the other side and then building all this on. So I'll keep filming as I do some more welding. I'll take you through the stages of finishing that manifold up there, how to set up your manifold pieces for purging, because it is something that's a little bit on the tricky side. I know most of the videos that you see online don't really give you the full story. They show people using foil and things like that, but there's more to it than that, or there are ways to make it a lot easier, and there are ways that it can be quite a pain in the bum to do. So I'll show you how I do it, which I think is a pretty easy way. I use a combination of, as you saw up there, I'm taking bits and pieces on and off, using foil, back purging them, assembling, using foil, or using a manifold plate or something to feed your back purge in. But I'll just guide you through the different stages as I'm doing them on that manifold. So bear with me, folks, and you can just hang out with me while I do a little bit of welding, and I'll just probably talk and annoy you at the same time. So let's go and do some welding. Before I go too much further, folks, I've got to repair one of my caps here. I'll just show you how either a piece of metal or something's poked into it and torn through it and made a little bit of a tear in it. So I'm just going to replace this, because I'm going to, even though like the root pass has been done and there's not going to be a whole heap of penetration with the next pass, it's really just to fill the weld up. There still will probably be a little bit of penetration here and there. It's all set up for purging. I may as well just run the purge while I do the second pass, and I might as well fix this, and I'll show you how I actually do this. You'll see people on YouTube do a similar thing. They'll be just using some aluminium foil to make their purge caps with, unless you're a pro and you've got expanding rubber caps and whatnot. But this is what I do, folks, and it's I find this is way better than just shoving foil over, which is what you see people do. They'll just stick the foil over like that, and that's all well and good, but if you're on the very end of something like we are here, And even if you're not, it's very, very hard to stop it coming off. So I've got a bit of a spool of some stainless lock wire here, and I lock wire all of the purge caps on, and it works extremely well, even on little spots like this that are a real pain in the ass because it wants to kind of slip off. But your foil wants to slip off as well as the lock wire, and honestly guys, anything that you can do to make these guys stay there while you're working is a bonus. Now I've already welded this area. This is something that's also a bit of a pain when you've got to weld right up to where one of your caps are for whatever reason. It can be very tricky. That's something that you just kind of have to work out on a case-by-case basis how you are actually going to achieve that. But a bit of thought and you can do anything. So we'll just trim that off. Now, what I do here with all the waste, once the cap's in position like that, I'll generally just trim the bulk of the waste off and then fold it back up over the lock wire just to get it out of the way so it's not catching on anything. So unless you poke a hole through your purge caps, you can pretty much just set and forget them. And every time I've tried to do this without lock wiring them, the bastards of things just keep coming off. So as I say, once you get it in position, just move the foil back up over the lock wire like so, and there it is. Now that shouldn't come off, okay guys, it shouldn't come off. Like I say, none of these have come off. This one was only a problem because I actually poked a hole in it. I bashed it with something while I was welding, because it can get a bit stressful when you're welding, when everything's red hot and you try and turn things. I'm using little bits of steel to sort of support things with. You know, stuff tends to get thrown around a bit. So that's fixed up now. I'll run the purge and I'll start doing the second pass over these welds. So I won't film while I'm welding, but as soon as I get this done, I'll show you the difference in the welds from having the root pass done and then the second pass over the top. Alright, so bear with me. I'll just turn the camera off while I weld this, and I'll put it back on as soon as I'm finished. Alright folks, I've now done the second pass on the manifold. Doesn't look as pretty as it did before, but it is now very nice and strong. The joints are nice and full, and it should be a good thing. So actually I might just set up a light and show you inside the manifold so you can see what the purged joints look like, where the penetration is. So let me just set this up. What will I do? Alright, that'll work. See if we can get a bit of a look in here. There we go. So you can see the penetration coming through on the joint, and it's all nice and shiny. Actually looks like it's been welded on the inside. So that's what you should get when you back purge. If you've ever looked at the inside of a stainless pipe that hasn't been back purged, believe me, it does not look like this. It is a mess. So yep, back purge weld folks, nice and strong, nice and smooth, bloody beautiful. Alrighty. So where I'm at with this now is I'm going to work out how to sort of refit all this together. I've actually removed this piece here because the main part of the manifold that we've just welded has shrunk by about probably 2 millimeters, 2.5 millimeters, and it's changed the angle of this pipe on the end here. So I've just got to make a bit of an adjustment to that. That's why it's off. And I've also got a little tiny little bit of an adjustment I need to make to these guys to get them to line up properly again. Once I get everything realigned, I will probably take this guy off and weld the bottom of this joint underneath here, where it's really shit to get to, so that then I can do the finish weld down through this way. But it's going to be very hard for me to get that way, so I'll do that joint first. So what I'll do is I'll take this runner off, cap it, run a purge in it, do that weld. I may even do both these welds, and refit it, check that it's still right, and you know, just sort of get it all together that way. So it's just a process of doing all this, and at the same time constantly checking to make sure that nothing's changed. It will actually hold its shape and everything better if you sort of leave it in one piece while you're welding it. But the problem is it's just a real pain in the bum to get to some of the areas, and it's a lot easier for me to disconnect it. And particularly one of the other main reasons why I'll generally disconnect something like this, anywhere where you've got any penetrations going in, what I do with these is often, not all the time, but I'll often just cut the hole through the middle, but not port it, not sort of go at it with a die grinder and get it perfect. And the reason being is that when you weld this, because of the angles that the pipes come in on, if there's no metal left in there sort of protruding inside, it can melt away and give you a bit of a hole. I just find it's a lot more robust to weld it with a bit of material still on the inside, and then pull it apart like I've done here. Once these inlets into the main log are all welded on, then just go at it with a die grinder and with various bits in the die grinder, just to get this ported absolutely perfectly and really nice and smooth, which you can see with these guys. It is ported out really well, because the problem is if you leave any dags in the manifold anywhere and it comes adrift during the heat cycle, it's going to end up in your turbocharger, and it's metal. You don't want it running into the blades of your turbocharger, because it more than likely is going to do some damage. So you have to be very particular about getting everything right, which is why you back purge, because you don't want bits of sugared stainless steel ending up in your exhaust wheels and things like that. So that's another reason why I pull the manifold apart and everything in this way before I do the final welding. It has positives and negatives. Like I say, it doesn't control it from distorting as much as it does if you leave it in one piece. Some manifolds you can leave them in one piece. It's like a lot of things, you've just got to do each individual thing on its merit to formulate how you're actually going to go about that. So that's where we're at with this anyway. This is all welded up. These two runner inlets have been ported and are beautifully smooth, absolutely perfect, and we're just now ready to work on these other sections of the manifold, realign everything, do any joints that we're going to struggle getting to later, and then we'll final weld that. So I'll just carry on with this. At each stage I'll pop the camera back on to show you where I'm at. So that's where I'm heading, folks. I won't keep filming and bore you while I'm doing things like regrinding angles and things on the pipes, but when I get to anything major, I'll flick the camera back on. Alrighty-o. See you shortly, hopefully with a bit more progress. I have a little bit of progress now, folks. As you can see, these runners have been welded up in all the places where they're quite hard to get to, and they've been refitted onto the main section. They've also been tacked onto the manifold flange plate. Yeah, it's looking pretty good. Like I say, I've got all the really hard spots, other than this real awkward one, which is right down in here. Everything else is done. So what I'm about to do is attach this to the purging manifold that I've made, and I'll bolt that down through this this bit of steel beam here, and bolt the whole lot together and set up my purge for welding this onto the manifold and doing these couple of joints that are still there to do. You can see I still only have a tack in this last section here, just above the V-band. I'll leave that till the very end. I'll probably re-flatten the manifold even before I do this one, just because it's my last opportunity for final adjustment on the turbo location when it's all finished. So I won't be doing that one, but I'll be doing everything else. So we'll get this bolted down and start setting up to weld it. You can see I'm using a countersunk bolt here to fix these down with. It just gives you better clearance around the bolt for welding, because it can be a little bit of a pain, particularly in tight locations, if you have a bolt head sticking up that's in the way. I'll get some of these tight ones in first, otherwise I'm not going to be able to get them in. It definitely gives you more room for your welding if you use a countersunk bolt to bolt them down to your purge block or whatever you're going to be using to weld it all together with. But yeah, you get the idea. The purge block does two things here. It works as a big heat sink to minimise the heat that sort of stays in the manifold, which is obviously going to cause a bit of warping or tend to set it up in a position where it can warp. You can see that there, folks, it's spitting in the middle, so it's obviously slightly high in that middle section still. So it's really just a matter of doing absolutely everything you can to eliminate as much as possible of the chance that things are going to move around. You'll never stop it, but you can certainly minimise it. Doing things like this is it's all just a big help. Like if you do nothing, it's just going to turn to crap. That's all there is to it. Getting there. You can see, folks, it looks pretty fancy, even though it's still a very basic sort of a home setup there. But we are certainly getting there. This is the purge line from my second regulator over there. I'll just hook him up. Taps on. Now all I've got to do is just make a cap for this end and poke a few holes in it. And we are bloody good to go. Couple of holes, a couple of breather holes in here. Should do nicely. And I'll go and turn the purge on. I generally blast this at about 10 litres per minute, and then I'll drop it down to about 5 when I do the actual welding. Blasting it will just tend to clear out all the atmosphere that's in there and replace it with argon. So that's set up quite nicely now. You can actually hear the argon coming out of the holes, and you can sort of feel it there as well. I'll let it run at 10 litres just for a few minutes, and then I'll just knock it right back for when I start the welding process. So that's where it is at the moment, folks. I'll get this all welded up, and then I'll give you a look how it turned out. Righto folks, she's all welded up now, or mostly welded up. Not 100%, but 98% welded up. As you can see, she's all welded up around the bottoms there. I couldn't quite get this section here finished, and there's also a little piece under here that I couldn't get to. I just don't have the right nozzle for my TIG to allow me to get into those spaces. But like I say, it is mostly done now. These remaining joint on each one of the ports is done. Just like the other stuff, they've been the root's been done first with a fusion weld, and then it's then been re-welded with filler rod over the top, which is why they tend to look a little bit daggy. I've also welded inside all the ports. I don't know if you can see that in there, but all the ports have been welded, so that helps me out a whole heap with blending the ports together, particularly on the short side radiuses. I'll go at these welds with a die grinder and maybe even touch them up a little bit just to get a really nice blend between the port runners and the ports. I did the same thing on the other turbo manifold, just to sort of clean it all up, and also the fact that they're welded on the inside makes them super strong at that point. And issues like I have here with this this weld not being complete on the outside, even though I will complete those welds, I probably don't have to, because as I say, it is completely welded on the inside as well. Just thought I'd show you that, folks. I don't know what everyone else does, but that's the Aussie shed way. So the manifold flange plate is slightly buckled even after going to all that extreme. Big fat aluminium heatsink for the purge block and then bolted to the beam. It's still proud in the middle. I'll show you how to flatten a flange plate on an exhaust manifold to the standard of machine shop flatness, just by using a handheld 4-inch angle grinder and some sort of a spotting plate, which I mentioned before. Now, I'm going to be using a surface plate, but you can just use a granite kitchen benchtop offcut, piece of glass, even a flat piece of ply. Basically anything that is flatter than this, which is pretty much everything. You know, like a pieces of aluminium extrusion like this, they're generally really flat, particularly if they're thick. That one's not that flat, but as long as you can find something that's really flat, you can use it to spot off and then transfer that onto this. So that's what's going to be coming up in the next video. So for now, I think we'll call this one here. And as always, folks, thanks for stopping by the Aussie Shed. Always a pleasure to have you here. If you like my content, remember to like, give me a thumbs up, subscribe to my channel, share the video to all your mates, and I'll see you on the next one. Cheers.